So 2.3, last section, is about volume. Okay. A lot of people mistake surface area and volume, right? Usually when I say something like, how do you find the volume, or no, how do you find the surface area of a rectangular prism? A lot of people will say length times width times height. But that's wrong, because that's talking about the volume of a rectangular prism. Okay. So it's important that you understand the difference between surface area and volume. Okay. They're very, very different things. Surface area is referring to the total area on the faces of the object. And volume is talking about what? The total space. A lot of people say density, but density is different. Density is how much a gram of that material weighs. Not a gram of that material, a cubic centimeter of that material weighs a certain volume of that material. But volume talks about how much space an object takes up. Right? If we had 60 students in this classroom, it would feel very crowded because the volume, the space inside the classroom is being taken up by bright young minds, such as yourself. In grades 8 and 9, you learned about 3 basic 3D shapes. We've already looked at them in surface area, but we're going to look at them in volume again. The rectangular prism, the triangular prism, and the cylinder. You should know how to find the volume of those 3 shapes. All of their formulas basically break down to this. You find the area of the base, and you multiply it by the height. So for a rectangular prism, right, maybe I'll just hold one up. You think about a rectangular prism. To find the volume of this, you would go length times width times height. Well, that length times width portion is the area of the base. And then the height is the area of the base times the height. Same thing with a cylinder. A cylinder is pi r squared h. Pi r squared finds you the area of the base. H multiplies it by the height. Okay? And it's the same thing with triangular prism. So they all follow this basic formula of you calculate the area of the base, you multiply it by the height. And that works for rectangular prisms, triangular prisms, and cylinders. But there are new shapes that you've been introduced to in this chapter, right? You've been looking at cones, you've been looking at pyramids, and you've been looking at spheres. Okay, so those will have new formulas. You cannot find their volumes by going area of base times height. They have their own special formula. So I've got a nice demonstration here to help you visualize these new formulas. You can actually see them at work. We've got a rectangular prism. Okay, a rectangular prism, and what's this?
Pyramid.
It's a pyramid, right? Now, they have the same area for the base, okay? Same area for the base, and the same height. Okay, how many of these do you think will fit in here?
3.
3? It was 3 last time.
Yeah,
3?
Maybe
Okay,
3.
let's find out. Okay, so here comes number 1. So there's 1. So definitely can fit another one in there. Running out of space. Can I fit another whole one in there?
Maybe.
maybe.
Okay, close that one.
Oh.
Oh, we did
There we
it.
go. 3. Okay? So, if I wanted to find the volume of this, I would just pretend like it was a rectangular prism and divide it by 3. Okay, so we just compared the volume of a cone to the volume of a cylinder. How is the volume of a cylinder related to the volume of a cone?
3, yeah.
Divide by 3, right? So, if I took the volume of the cylinder, which is the area of the base, pi r squared, times the height, and I divided it by 3, that would give me the volume of the cone, right? So that's our formula, pi r squared h, that's the volume of a cylinder with the same base and same radius, same height. And we divide it by 3 because 3 of those cones fit inside that cylinder. The pyramid was similar, right? We went length times width times height. That's the area of the rectangular prism. And how many of those pyramids fit inside of that rectangular prism?
3.
3, right? So if I divide this by 3, that gives me the volume of the pyramid. Now a sphere is a little bit different, right? Remember with the surface area of a sphere, I just gave it to you. I'm going to do the same thing this time. Okay? Surface area of a sphere is pi r cubed. 4 over 3 pi r cubed. Now that's an easy one to confuse with this guy. Right? This one is the surface area of a sphere. Notice both formulas have a 4, both of them have pi, both of them have r. The way I remember it is that volume units are cubed, and so in the volume formula, r is cubed. That's how I remember which goes to which.
So
Area units are squared,
over
and so this guy is squared in the area formula. Okay, so that's how I remember between the two. I just remember, oh yeah, cube units are for volume, so 4 over 3 pi r cubed is for the volume of a sphere.